writing formulas. Now, and I know you noticed I changed my shirt up, okay? I decided to change things up. You know, variety is the spice of life here. I got a nice little sunny shirt. This is my fun shirt. Good go sailboats and palm trees and woo. All right, so a little more sunny fun time. It's good. The weather's getting better outside, so I have to get away from the flannels anyways. Okay, moving on here. Writing formulas, the opposite of naming compounds. This is easier, it'll be quicker, I promise. You've been dragged through the mud on naming compounds, and writing formulas is going to be easier for us. So writing formulas, level 1, level 2, okay, get your sheet, level 1. Let's start writing some formulas. All right, first one, it says potassium bromide. Write the symbols down for the word. This is easy. Write the symbols down for the word. Now, if you don't know the symbol for potassium, go to your periodic table and look it up. Write down potassium, okay. Bromide, now we know by naming that comes from bromine, so you find that in the periodic table. It's Br. Okay, potassium bromide. Got my potassium symbol, my bromine symbol. And is that it? Maybe. Now what you have to do is check the charges. You need to check the charges. Now I'm not talking about hockey player check, which I wish they'd bring it back. I miss my Bruins. My Bruins, man. I miss you. Check the charges. Okay, what I mean by that is go to your periodic table. Oh, let me get the other one I gave you the other day. Oh, I'm exhausted. I am so out of shape. All right, so this periodic table here, the one I gave you the other day, has the charges at the top of the groups. Check the charge of potassium. Potassium is in the +1 group. There it is, +1. So it gets a +1 charge. Bromine is in the -1 group. There it is, -1. Now, what you want to do is make sure that those two things are equal. If they're equal, you're done. That's it. What I mean is equal and opposite. I mean, they're not equal in terms of the positive, negative, but the number values are equal. +1 and -1 balance. That cancels out. Get a nice neutral compound. That's what we want. And so that's it. I don't do anything else. That's just KBr because those charges are equal and opposite. Done. Move on. See? Piece, oat cake, pie, crumpets, cookies, whatever your favorite dessert is. All right, let's see. Let's go to number 3. Magnesium chloride. Magnesium chloride, number 3. Magnesium. What's the symbol for magnesium? Look it up. Magnesium. Mg. So write the symbol down. Chloride comes from chlorine. Okay, chlorine is Cl. Okay, is that it? Are we done? Maybe. Maybe not. Let's check. Check the charge of the magnesium. The magnesium's out of the +2 group. +2. Chlorine's out of the -1 group. Uh-oh. Rastro. Again, Jetsons reference. Love the Jetsons. Awesome. Rastro. +2, -1 aren't equal and opposite. That means I'm going to have to do one more step. It's not a hard step, so stick with me. Not hard. If the two charges aren't equal and opposite, you take the charges and you crisscross them and use the charge number, the 2 and the 1, as subscripts. So this 2 crisscross. We all remember our 1990s hip-hop band, Crisscross. Oh, I was into it. You should have seen me. I was a fan. Oh, big time. So 2 comes down for the subscript for the chlorine. Okay? The 2 and the 1 get crisscrossed, used for the opposite element as their subscript. Subscript means down below. The 1 gets pulled down for the magnesium, but we don't write it. You could. It's not wrong if you do. I mean, you could do this. It's water, H2O1, but you don't ever see that, do you? It's not wrong. It's just that it's not ever done. You don't put the 1 in. I mean, you can do it, but people are going to laugh at you behind your back and make fun of you. And you don't want that. You don't want people making fun of you like that, so don't do it. So the Mg does not get, and it gets the 1, but we don't write it. So just MgCl2. Done. Oh, by the way, let's name this one. I didn't do that in the last video. Name this. It's water. Right, that's its common name. Okay, just like NaCl is table salt, but it's really sodium chloride. How would you name that using chemical terminology? That would be, okay, it's binary. No metals. See, we're going through this now. It's getting quicker, isn't it? It is. You're learning that flow chart in your brain. Okay, no metals, so therefore I have to use a prefix method. So this would be dihydrogen monoxide. Dihydrogen monoxide. Okay? Man, don't drink that, man. It's got dihydrogen monoxide. Dihydrogen monoxide, that's a deadly poison. Ooh, sounds nasty, doesn't it? Dihydrogen Hydrogen oxide. Stay away from it. Nasty government conspiracy. They want you to drink it. Oh, yes. All right, moving on. Let's see. How about number 5? Sodium oxide. Sodium. That's the symbol for sodium. Oxide comes from oxygen. Sodium's in the +1 group on your periodic table. Oxygen's in the -2 group on your periodic table. Those two charges are not equal and opposite, so I have to crisscross and use for subscripts. So the 2, crisscross it, comes down for the Na. The 1 comes down here for the oxygen, but I don't write it. Okay, so that is my sodium oxide. Okay. Let's move on a little bit here, because you're getting this, right? You're getting it. Okay. What about magnesium oxide, number 15? So I've scooted ahead to magnesium oxide. Sounds the same, right? Maybe it doesn't, it's not quite the same, but it sounds the same. Magnesium oxide. Okay, magnesium +2. Oxygen -2. Balance. They cross out, they cancel each other out, you're done. That's it. MgO. Oh, see, I told you, it's a piece of cake. Okay, let's flip over to the other side here. Okay, let's go down to number 6, phosphoric acid. I just want to point that out because it's an acid, and it's one of the basic acids, common acids that I want you to know. It's phosphoric acid, H3PO4. H3PO4 is phosphoric acid. So I just wanted to put that down as a reminder. There are some acids that you just need to be able to identify and know how to write the formulas for. Okay, let's go to number 7. Number 7 says tin. Ah, look at that. It's got those parentheses around a Roman numeral. And chloride, tin chloride. So tin, I have to find the symbol for tin. Okay, got it? SN. And sometimes the students will ask, that's weird, why is it that some elements make sense? C for carbon, H for hydrogen, O for oxygen, makes sense. Tin, SN, what the heck were they thinking? Were they on drugs? Were they drunk? I mean, what the? No, actually, some of the elements have been known for a really long time. And back in the day, any kind of science, alchemy, was done in Latin. And the Latin word for tin is stanic, or stanus. You've heard of stanus. Stanus Baratheon. Yeah, Game of Thrones. Okay, hang on. Let me check this out. Okay, you ready? I'm going to turn you around. Yeah, you see those? Those are 3 banners hanging in the back of this room. Yeah, there we go. Game of Thrones banners. Yeah, you're all jelly. I know you are. You're so jelly. Okay, jelly are you? Yeah, Stannis Baratheon. No, okay, sorry, get back. Stannis or stanic would be how you would say tin. Fe, that's another one. It's weird, right? Why isn't iron I? Well, iodine is, but why isn't it I? Because it's ferric or ferrous. You know, you've heard of Ferris Bueller. Okay, you've heard of. Okay, so those are Latin terms, old elements. Copper is cupric or cuprous. Na is sodium. That's natrium. Okay, it came from the word natrium, which is Latin for sodium. Okay, so this one is tin. So I just erased it. I needed that. Tin. Now, it tells me tin 4. It says that. It does. It did. I remember. It said tin 4. That makes this easy. I know what the charge the tin is using. I don't have to figure it out. Remember, naming compounds, you've got to figure it out. You've got to look, okay, this is total negative, total positive, how many, divide, get the... You don't have to do that. It tells me what it's using. It tells me it's using the +4 ion charge. It says tin 4. Piece of cake. Then it's chloride. So that's Cl. All right, so that's, did I look at the right one? Yeah, tin chloride. So go ahead. We're going to crisscross because we have chlorine has a -1 charge. +4 and -1 don't equal each other, not equal and opposite. So crisscross. Take the 4, bring it down. Take the 1, bring it down, but don't write it. And we have SnCl4. That's it. So much easier when you're given the charge than when you have to go figure it out for yourself. Well, So I like this, writing formulas. Whew, from names, man, easy. Okay, let's do one more here. I'll do two more. Number 17. I'm doing this for you lazy people who haven't gotten your sheet. Okay. I'm enabling you. I'm enabling you to be lazy. How's that? I'm an enabler. Iron is Fe. And it has Roman numeral 3 after the iron. I know it's using a positive 3. Easy. Sulfite, and be careful there, not sulfate. Sulfite, one of those I told you to know, SO3. Now, check this out though. Sulfite, -2 charge, right? Look at your polyatomic ions I gave you. It's -2. That -2 does not cancel opposite and equal with this positive 3. So what do? Crisscross the charges. Oh, you don't have to crisscross the 3 down here because there's already 1 there. So that's all set. No, Michelle, it's not, okay? Well, yeah, it is. How come you're giving her a hard time? Billy, relax. It's that angsty Billy kid again. He's so annoying. Billy, listen. The SO3, the 3 is part of the whole ion that is sulfate. So really what you need to do is think of these things with parentheses around them. There is 1 SO3 here. I need to put the 3 outside of the parentheses. So if you have more than 1 polyatomic ion, you put parentheses around that. And if you remember from our thingy on naming, that's what they did. They did that. They put parentheses when there's more than 1 of them. So that's what you do. So we'll take 3 sulfites, put a 3 outside the parentheses, and take the 2 and put it down here for the iron, crisscross. Fe2SO3, bracket 3. There we go. All right. See, Billy? All right. Let's do one more. And then I haven't mentioned one thing about one other formula, kind of way of naming things, and it'll be quick. Let's see, last one. Let's do the very last one on the thing here. Oh, that's got to be impossible. It's the last one. It was always the hardest. Ammonium phosphate. Ammonium is a polyatomic ion you just need to know. If you go look up ammonium on the periodic table, you're not going to find it. It's a polyatomic ion. Ammonium has a +1 charge. Phosphate, we used that earlier. It's a polyatomic ion. So here's a back-to-back polyatomic ion compound, 2 polyatomic ion. Phosphate's a -3. All right, -1. All right, +1 and -3 don't balance. So I'm going to have to crisscross my charges. So this time the -3 comes down and it goes outside the parentheses for the phosphate. The 1 goes down for the phosphate, for the ammonium. For the ammonium, 3 comes down outside for the ammonium. The 1 goes down for the phosphate, but I don't write it. So I don't have to put parentheses around it. You can, it's just, again, people make fun of you at the water cooler when you walk away, you could do that. So don't put the 1. NH4, PO4. All right, one last thing before we wrap up this writing formulas, which naming compounds took 35 minutes. Okay, this is less than 15 minutes, so less than half the time to do this. Much quicker, much easier because we've gone through the naming, so it made it easier. But there is one more thing on your sheet where it is. Here it is. If you look down here at the bottom, it says naming rules. Ich versus us. Now, the stock method, where I get on there, stock method we've done. The stock method is the Roman numeral method. So stock and Roman numerals, that's what we're using to determine the charge of a multi-charge compound. So yes, we've done that. Prefix, we did it. Carbon dioxide. Ich versus us. Don't worry about it. I'm not going to go over that naming method. It's a very old naming method in 1964, and we all remember where we were in 1964. I remember it clear as day. The International Union of Physical and Analytical Chemists, UPAC it's called, came up with a naming system, and they determined that ich and us, you're old school, you're out, you're gone. We're not using that method anymore. We're using Roman numerals to determine the charge of things like iron or copper that can have multiple charges. The ich I said earlier, stan us or stan ich. Oh, you see what I did? Stan us, O-U-S, stan ich, I-C. They have both different endings. That's another way of determining the charge. Ich, I-C means I high. You think of it as being I high. So if something was like tin. It can be a +2 or a +4. This is the high charge, so it gets the ick ending. This is the low charge, so it gets the us ending. It's actually easy to remember. Stan ick. Stan ick would be using the +4 charge. Stan us. O low would be using the +2 charge. I just wanted to mention that because sometimes on the old stuff doesn't go away, and I think it's Procter & Gamble that still uses stannous fluoride in their toothpaste, which is what gives you the fluoride, the fluorine. But if I'm not mistaken, you look at the back, look at the ingredients. I still think they use the old naming of the compound, so it doesn't go away. So if you ever see that, just know that's an old way of naming multi-charged elements. I'm not going to have you do that on a test, so don't worry about that on a test, but do know your Roman numerals. All right, we are done with this. Whew, that was a rough week. All right, finally, we are done. Well, a rough evening. Bye.